So these are angles in a triangle. Find the measure of each angle indicated. And these require us to apply the new idea that we learned on Friday about the angles in a triangle. And that's an idea that you actually already knew from middle school, but then we had to prove it. So now we're talking about the application of the idea. So we know that the angles in a triangle have to add up to 180 degrees. So if I know two of the angles, right, I know that this little box means 90 degrees, and I know they just told me this is 40 degrees, then I know that whatever I put here has to add up, these three have to add up to 180. So the easiest way to figure that out, add up these two, that's 130 degrees, and then subtract that from 180 degrees. The difference, 50 degrees, must be this missing angle. This has to be 50 degrees if the three are going to add up to 180. So that means that it should be pretty simple for you to do 1, 3, and 4 as the application of the triangle sum. So now looking here at 5, 6, 7, 8, we're having to apply just a little bit more, some more of the ideas that we learned, right? So, for example, right here, number 7, they're wanting to know not something inside, one of the interior angles, they're wanting to know this angle right out here. And it may not be obvious how to find it, but it should be obvious at least how to find this one, right? So one of the things about applying these ideas is to move forward with what you're sure you can figure out, and then see if from there you can make another step. So we definitely know we can find this one, because these two added together would be 50, right? And then all together they need to add to 180, so 180 minus 50 is 130. So we know that this interior angle is 130. And now we need to look, do we have a way to relate 130 to this angle out here? And yeah, we do. They're actually vertical angles, right? Because if you extend this line and extend this line, they both share those extensions and they're opposite of each other's vertex. So they're vertical angles, which means that then this has to be 130 degrees too, because of the vertical angle theorem. So the triangle sum theorem plus the vertical angle theorem got us to this. The same idea here, over here, right? What they're asking for here is the exterior angle right here, right? And remember, an exterior angle is when you extend one of the sides of the triangle and then they're adjacent. Notice the difference here where the vertical angle was what we applied because we extended both sides. And then it was the opposite. It was opposite that vertex from the interior. That's not what's happening here. These are called exterior angles. You extend one side and then it's the angle adjacent to the interior angle. So this is an exterior angle. This is an exterior angle. And that's different from this one, which is not considered exterior. So this is a question where we have to apply ideas about exterior angles. And I think the easiest way is to just take it piecemeal by linear pair. These two make a linear pair, right? So because they make a linear pair, by the linear pair postulate, they should add to 180. So that means 180 minus 155, that should be 25 degrees. So this angle in here needs to be 25 degrees. So again, remember, we're trying to find this. We're not sure how to do that, but move forward with what you can find. I can find this angle because they make a linear pair. Now that I've got that, look, I have two angles inside a triangle, which means I can figure this one out, this angle out, because of triangle sum theorem. I can add these together, 60 plus 25, that's 85 degrees, and then subtract from 180, right? And then that should leave me with 95 degrees. So this angle right in here should be 95 degrees. And then from there, I should be able to find this one because, again, this one makes a linear pair. So I subtract 180 minus 95, and that gets me back to 85. So that should be 85 degrees, right? Now notice that you have these two being the same, right? So that's an interesting Oh, no, not the same. You notice that you have this being the same as the sum of those two. So that would have been a way to skip over this right here. To skip over that is to apply the exterior angle theorem. So you could have skipped the step of finding this one and just use the exterior angle theorem to find this one. However, it's okay if you needed to take that extra step with the linear pairs because those are more simple. So sometimes the exterior angle theorem is just a shortcut. Linear pair postulate and triangle sum theorem is all you need in order to find this. So your job is to apply the things that you know with 5 and 6.